So if we have that interval estimate, that question, I think it had said that 78 hours. Normally, we say 78,000 hours. Eh? They refer to the original question. The part B, they had said we predict for 78,000 hours. So for y predicted, will be equal to, we submit the equation. The equation was 2 that what? 2 that 1.38 plus 11.96, you multiply by 78. Give me that value. You multiply by 78. Eleven 64.26. 1164.26. This T 1 minus 0.05, obviously at 95%, and 12 minus 2. Go to the T tables and tell me what that value is. You go to 2 tail or 2 confidence. Then you move towards 95%. Then look at where there is 10 degrees and tell me what is there. 2.2281. Good. Now SE, we already have it. So then we are going to have 1164.26 plus or minus 2.2281 multiplied by SE, which is 85.4675. So 1164.26 plus or minus, give me that answer to 2 decimals. $90.43. So on the lower side, when we subtract 1164.26, you less 190.43. $973.83. This is the Y predicted. Then you add 1354.69. Good. So that is how we get the standard error of estimate. The standard error of estimate. Now we go to the third test. We go to the third test, which is called F test. Now, F is simply used to measure significance of the relationship. By that, we want to see how, what amount of importance you attach to that relationship. It is what people would say, does that person take me as a priority, or I'm just one of the very many options available to him or her? So this one is done using a hypothesis test. So it proceeds like this. So utaandika hypothesis, and the null hypothesis, utaandika hivi, H naught is that the relationship is not significant. 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 In the alternative, you write that the relationship is significant. The relationship is significant. Is significant. Next is called significance level. Significance level. And in the significance level, we will say let alpha to be 0.05. Alpha to be 0.05. The next thing is called test statistic. Now, test statistic is F is given as R squared. You divide by K minus 1. K minus 1. You divide by 1 minus R squared. You divide by N minus K. N minus K. So our F calculated, I think to go to the part R squared as 0.77 what? 77.36. So 36. Now this one you're dividing by 2 minus 1. Then you divide here by 1 minus 0.7736, which is divided by 12 minus 2. 12 minus 2. What's the answer? One 1696. Okay, the next is decision rule. And in this decision rule, when you are in F text, the numerator degrees of freedom is equals to 1. That one here, not 2 minus 1. That's 1. Alafu hii inaitwa denominator. 12 minus 2, that is 10. So the denominator degrees of freedom, they are 10. The denominator degrees of freedom, they are 10. So now, this is x-axis, and this is y-axis. And then Here we will say accept null, and here we will say reject null. If you're on that side, this is 0 here, and this is F critical. Obviously at 0.05, that's the significance level. So what to do, get your tables there. Huko mwisho, you look for the F tables. F tables. When you get there, you can see where there is numerator degrees. Those are the columns. So we will go to column number 1. And the denominator degrees, those are the rows. So you'll go through number 10. So tell me what is there at the intersection of column 1 to 10. What is there? 4.96. 4.96. Okay, so with that now, we come here and make the conclusion. We come and make the conclusion. So the conclusion is we are going to reject null hypothesis. We reject null hypothesis since F calculated is greater than F critical. That is 34.1696 is greater than 4.96. It's greater than. The meaning of that. The meaning of that is that the relationship between machine hours, and electricity expense. The relationship between machine hours and electricity expenses in the above case is significant. In the above case is significant. Good. We go to number 4, and then we need to correlation coefficient. Correlation coefficients are. So I told you the other one inakuanga na S, but this one does not have S. The Spearman inakuanga na S. Some people, especially when they're using the computers, they call it multiple regression. Or multiple R. Let's just call it multiple R. So when you see multiple R, it means the same thing, correlation coefficient. Now this one is a very simple value because it shows us two things. As we said earlier, it shows us the type of the relationship that is existing, and then it shows us the strength of the relationship. So with that, we can later on compute the value. So the value of R is simply the square root of R squared. So tumesema ni 0.7736. That was our R. So give me the square root of that. $8795. 8795. So we can interpret that, or we can comment about it. We can give the meaning of this. Give the meaning. I told you how close it is to 1, the stronger the relationship. So this one you can write that this value shows a very strong direct relationship. Shows a very strong direct relationship between machine hours, and electricity expense in the above case. And electricity expense in the above case. Electricity expense in the above case. Okay, so that one is that simple and as good as that. Number 5, we're going to a standard error for the slope. Standard error for the slope. Standard error for the slope, SB. Standard error for the slope, SB. Right, that's we just get the value. So the value here, SB, is normally given as SE. You divide by the square root of the sum of x minus x bar, you square. You get that square root. So the SE tulikuwa tumepata 85 point what? So sasa enda kwa table ulisomee hii value that we had gotten for x minus x bar. But what is the answer? 2.046. So still in this error that shows the value, the error that is contained in the value for the slope, we also get what we call the interval estimate. The interval estimate. So the formula for getting the interval estimate for the standard error for the slope is given as b plus or minus t, 1 minus alpha out of 2, n minus 1, you multiply by SB. You multiply by SB. So our B was 11.96. Is it? The slope. 11.96. So plus or minus t, 1 minus 0.05. That is if we are testing at 95%. Then 12 minus 1, you multiply by 2.046. 2.046. Sasa itakuwa 11.96 plus or minus 11.96 plus or minus 'Go to the table. Go to the table. Unisome hii now utasoma kwa row number 11 because those are the degrees. The T table. This is T. The T table. Got 1 confidence. Two confidence. Unarudi nyuma kwa 95, then uteremke kwa number 11. .201. So you multiply by 2.046. So 11.96 plus or minus multiply this and give me to 2 decimals. Four points. 4 points. So we can just put that to 4.5. Okay, so when you subtract, $7.46. And on the upper side, 16.46. So that is how we get the standard error of estimates. Number 6 under that is called t-test. T-test. So t-test, it is used to test the significance of the independent variable. How strong is it as an explainer of the dependent variable, how strong it is. So in that case, we do a hypothesis test. So we begin like this. So you say hypothesis. Hypothesis. And in the hypothesis, you say H0. You say X. H0 inaandikwa. X is not a significant determinant of Y. X is not a significant determinant of y. In the alternative, HA, say X is a significant determinant. X is a significant determinant of y. Significance level. Significance level. In the significance level, we can rate alpha to be 0.05. 0.05. Test statistic. T is given as B out of SB. So this is 11.96. I need to say T calculated. It is 11.96. You divide by the error tulikuwa tumepata 2.046. 2.046. Napata 5.8 455. Okay, so we go to the next one, which is called decision rule. Now, decision rule, the degrees of freedom will be 12 minus 1, which is 11. And obviously, this is a two tails. These are two tails. These are two tails. So sasa hii nayo inajipanga namna hii. Here we normally say reject, null hypothesis. Here we say accept, null hypothesis. Here we say reject, null hypothesis. And this one here is minus T critical. Na hii T ni ile tumesoma tu, ni the same thing. Tunakumbuka hii tumesoma at 11 degrees at 95. So it's the same thing. So nitaandika 2.201. Na hapa positive T critical, it is positive 2.201. 2.201. So conclusion, as you can see, we will reject null hypothesis since T calculated is greater than T critical. That is 5.845 is greater than 2.201. 5.845 is greater than 2.201. What does that mean? What does that mean? The meaning is machine hours are a significant determinant. Machine hours are a significant determinant of electricity expenses. Significant determinant of electricity expenses in the above case. Significant determinant of electricity expenses in the above case. So those are the 6 tests of the goodness of it. The 6 tests of the goodness of it. Now we go to the third category. The third category is C, which is assumptions used in regression analysis. Assumptions in regression analysis. What are some of the assumptions that we use? Now, first of all, it is good you get to know that an assumption is a condition. Those things are already written in your notes, so this one will be very brief. An assumption is simply a condition that must be satisfied for what you are saying to be true or to be maintained. Now, regression analysis is founded on 6 assumptions. And we are going to go through all of them as we confirm whether they have been maintained or not. So the first one is called linearity assumption. Linearity assumption. It's called linearity assumption. Linearity assumption. And what this linearity assumption means is that the relationship between X and Y is linear. And there are usually 2 ways in which you can test this one. And as I've said, these things are already written in the notes. I'm already explaining. I will be telling you what to write. So if you want to know whether the relationship is linear, you have the values of Y here and the values of X. So you simply plot. And when you plot them, you check whether they give you a straight line. So if you are to plot and get something like that or something like this, that tells you the relationship is linear because they are showing a linear pattern. But if you are to plot and find something moving like this, now that one is non-linear. It's not straight. That's the first way. Now, in our case, we shall not use this method because we shall not plot. But in case they present to you, although in your exam, I don't think they can, you simply check, is it producing a straight line? The second way in which we use to test is you develop the equation and you judge whether it has taken the shape of y is equal to a plus b x. We already have an equation. Your equation to go to the 2 that 1 plus what? Plus 11.96. Sasa tarudi hapa tuandike hivi. Tarudi uandike hivi. The above relationship is linear. The above relationship is linear. The above relationship is linear since the equation obtained, y is equal to that 1.38 plus 11.96x takes the form of a linear equation, y is equal to a plus bx. Y is equal to a plus bx. Yeah, that one is as simple as that. You just develop an equation, check whether it's compliant with this format. Yeah. The second assumption, I will not write them here full like they appear in the notes. I'll just write a few words which are connecting. So this one is zero mean assumption. Zero mean assumption. Now, what this means is the error terms, they have a mean of 0. The error terms, they have a mean of 0. And what you do, you simply confirm. So we can have the value here. We can have the value where we say E bar is supposed to be given as the sum of EIs divided by N. And remember, these EIs are the Y minus Y predicted. So nataka uende kwa hiyo column yenye tukitengeneza kwa our data ya Y minus Y predicted. Unisomee toto yake huko chini. .04. Okay, now divide this by 12. So what can we comment about that? What can we say? You think this is Z? So in the comment, the error terms in the above case. Error terms in the above case. Can be said to have a mean of 0. Can be said to have a mean of 0. Since the computed mean, 0.0033. The computed mean 0.0033 is too small. When compared, is too small when compared to the original values of y. To the original values of y. Yeah, that's how you go about it. But if you do not want to use the word too small, you can also do a hypothesis test. But that is good enough. Number 3, constant variance. Constant variance assumption. What this says is the values of the error terms do not depend on the values of X. I want you to go to the original data. Go to the original data. When you are there, you could submit the first value of X was what? 72. We submit the error term. The error for 72. Negative 22.5. The second value. The second value of X. 55. We submit the error term. Negative 69.18. The third value, that 9, the error, 22.18, positive.
Yes.
The fourth value, 60, the error, negative 48.98. The next value, where X?
49.
Nataka unisomea 39 inakuja after 49.
Yes.
Sasa nisomee ya 49.
52.58.
Then hii ingine.
22.18.
So this is how you check by observation. You see now this one, this is 39 and this is 39. Now the errors zinafanana. So you can say that the error term is depending on the value of X. But that's just one value. You need to check to pick the pattern. And the pattern is picked like this. Ukiangalia hapa, the value of X has gone down. And the value of the error has also gone down. Actually, it has increased, not gone down. Or you can see for equality of purposes, the error of the signs, let me put it that way. That's gone down. So you see your pattern coming in a. But now when you come here, the value of X again has gone down. So you would expect the error also to go down. But what is happening? It is increasing. Actually, even this one we should have seen is increasing. Then this one, you can see it has gone up. And this one has decreased. So they are not moving towards the same direction. You cannot say they are depending. I cannot say they are depending. So, using visual inspection methods. Using visual inspection methods. Using visual inspection methods. Visual inspection methods. The error terms do not appear to depend on the values of X. Do not appear to depend on the values of X. As a result, they have a constant variance equal to 1. As a result, they have a constant variance equal to 1. Number 4, inaitwa normality assumption. Normality assumption. Normality assumption. Normality assumption. Now this one, it simply says that the error terms, they follow a normal probability distribution. that way. And what you do, there are two ways of confirming this. The first way is you plot the error terms. You plot something we call frequency polygon curve. And you judge whether it is taking this shape. But for our case, we shall not plot. What we do, we already have covered normal probability distribution. And we know for normal probability distribution, the mean is always 0, and the standard deviation is always what? 1. So we already, in our two preceding assumptions, this one we have said we have a 0 mean. Here we have said we have variance of what? Of 1. So those are the two main characteristics of a normal probability distribution. So we are going to put it this way. The error terms in the above case. The error terms in the above case can be said to follow a normal probability distribution. Can be said to follow a normal probability distribution. A normal probability distribution. Since they have a mean of 0, since they have a mean of 0, and a variance of 1. And a variance of 1. And a variance of 1. Number 5 is absence of autocorrelation. Assumption. Absence of autocorrelation assumption. Now, what this means is that the values of y are not influencing each other. They are not influencing each other. And it can be done in two ways. The first way is where you check by visual observation, whether by knowing the first values of y, not the original values, go to the original values. You submit the first value of y, 1020, the second value, 820, the third, 720. Now look here. What's the difference here? The difference here is like we have subtracted 400. Kutoka hivyo tufike hivi. Oh, sorry, 200. Oh, this is that is 200. If this is the pattern, that you must subtract 200, then here I should have gotten 600 and what? 20. Ndio nikuwe bado nimesubtract what? 200 from here. Then the next one I subtract 200, ndio nibaki na 420. But you see now here, instead of getting 620, I am getting 720. The next value, number 4, after 720 is what? 900. Now you see, instead of getting 420, I'm getting what? 900. So that tells you, by knowing a few of them, you cannot tell the others. So those values are not correlated. But kama ukijua a few of them, you can tell the others. For example, nikikwambia this was 20, this was 25, and this was 30. Can you tell me the next one? It will be 35, and the next one will be what? 40. Now, if you are able to get this kind of data, this one will say it has autocorrelation. As in, ukijua a few of them, you can tell the others. So, you can write by visual observation. By visual observation. The values of electricity expense. The values of electricity expense values of electricity expense are not influencing each other. Are not influencing each other. First of all. Using BWS, 2 brackets 1 minus R, that is 2, 1 minus 0. Because we got the 87 what? The correlation coefficient was 8795. Give me this. The same using BWS, which is equals to 2 brackets 1 minus R, which is equals to 1 minus 0.241. 0.241. Comma, because tulikuwa tumesema using BWS, so andika comma. It can also be seen. That there is no autocorrelation. In the values of electricity expense. The values of electricity expense. So that is how you go about it. Now the last one, number 6, is called absence of multicollinearity assumption. Absence of multicollinearity assumption. And in this, now this one, we are not able to test because in Atomica, where we have more than one independent variables. And simply it says that the independent variables are not influencing each other. The independent variables, just like in an example, the candidates are the independent variables. No one is supposed to influence the other one. So for our case here, we are not able to test because our data is just one value. So that is how you go about it. See whether there is any question. So as I said, almost every paper of your past papers has a question on regression analysis. As a question on regression analysis. So I would like you to go through them, you answer, and in case you have any challenge, you can let me know. So that brings us to the end of that area and to the beginning of another one. Which is called decision making. That's the next area of concern, decisions making. Now, for those who are online, I've already sent the notes. I think for this one, because of our time, ability to ongea. I don't know whether you're able to copy the notes later. For those who are physical, let me get you the hard copies. So in decision making, what you're doing is simply making a choice. That's what we call a decision. A decision is a selection of an option from a set of various options that are available. Like now this morning when you woke up, actually even before you woke up, you had several options. One of them is coming to class. The other one was continuing to sleep. The other one was you wake up and attend to other matters. But you quickly considered all those and finally settled for coming to class. That is a choice you made freely. Now, when making a choice, we do so that we achieve a particular goal, a particular objective. It is very clear, I believe so, in your mind while you are attending this class. When we are again making these choices, we are guided by two things. One is what we call personal preference. A personal preference is what you prefer as an individual, what makes you happy. And this one is what in layman's language we call our opinions. And people have different opinions. My opinion is not your opinion, and none of them is wrong. That's why when you criticize people, they tell you it's my choice, it's my opinion. You keep yours, then make it mine. The other thing, and maybe before I move out of that, is the foundation of a very popular statement that says the beauty is on the eye of the beholder. What I find good is not necessarily what you find good. What I find beautiful is not what you find beautiful. The other thing is risk appetite. Now, risk is the probability that what you get is different from what you are expecting. And it is usually very bitter because it involves loss of resources, it involves loss of time. It's like when you come to this class and I'm not here, that's a risk because you have lost your time, you have lost your resources. How you react to that is called risk appetite. And we have three types of reactions or three types of decision makers. One of them is called risk neutral. These are guys who do not care about the risk. We have some others known as risk takers. These are guys who are very keen in risk and they go for the highest risk so that they make the highest return. We also have some other group that is called risk averse. They are also keen on the risk, but they go for the lowest risk. Now we have three measures of risk, or rather two measures of risk. We have what we call the standard deviation. We have what we call the coefficient of variation. And the higher the values, the higher the risk. So I want us to just go straight and look at measurement of risk. So already you have written the topic is decision making. Decision making. So I want us to deal with question 1 in the handouts. Question 1 is the measurement of risk. Measurement of risks. Measurement of risks. When you are making decisions. So the question says that an investor has a choice of investing in either one of two shares, equity 1 or equity 2. The returns from both equities are uncertain. The average rate of return on investment in equity 1 is 12%, with a standard deviation of 2%, while the average rate of return on investment in equity 2 is 9.5% per annum, with a standard deviation of 1.8%. The rates of return on both equities, they should be equities, not inequities, they should be equities, are assumed to be normally distributed. Required, on the basis of minimizing risk, advise the investor which of the two equities will be better and clearly state your reasons. So we are going to have it like this. We are going to have the measure here. We are going to have the measure. We are going to have equity 1. Then we have equity 2. Equity chosen by a risk neutral, taker, and averser. I've told you we have 3 types of decision makers. We have 3 types of decision makers: a risk neutral, risk taker, risk averser. Be fast in designing that table. Now, the first measure is the mean. The mean, remember mean, we also call it expected what? Value. Expected value, which is normally given as either X bar or the expected value of X. Those are things that we have looked at. Now, for equity 1, according to this question, the average return is 12%. At equity 2, the average return is 9.5%. Now, this guy called risk neutral, he makes a decision based on averages. And he goes for the higher or the highest. So he's going to go for equity 1. He's going to go for equity 1. Now, the risk taker does not use that. So this one is say not applicable. And the risk averser does not use that. So that is not applicable as far as that guy is concerned. So that is the first measure you can use to make a decision. The second thing that people use to make decisions is called standard deviation. Standard deviation. Now here we shall just use delta, the normal way, the standard deviation. So for the standard deviation, in the first one, they have 2%. 2%, and this one they have 1.8%. 1.8%. Now the risk neutral guy does not compute risk. He does not compute risk, and therefore he does not use the standard deviation. So for him, this is not applicable. For someone with risk neutral, you have a risk taker will compute the standard deviation and will go for the higher risk. And the higher these values are, the higher the risk. So a risk taker will prefer this one. So you will go for equity 1. But a risk averser, you will anatokea risk. So you go for the smaller one. So you prefer this one. we prefer that one, risk averse. Then the other one is called coefficient of variation. Coefficient of variation. Coefficient of variation, and this one we know so well. We normally put it as CV. And this CV, we already know how it is computed when we are in statistics. We get it as the mean, or rather as the standard deviation. You divide by the mean, you multiply by 100%. So give me that. You get the standard deviation, you divide by the mean, you multiply by 100%. That tells us we have what? 16.67%. You come and do the same thing here. 1.8 when divided by 9.5 times 100. $18.95%. 18.95%. Sasa, as usual, tumesema the risk neutral guy does not consider risk, so that is not applicable. Does not consider risk, so that is not applicable. Then the risk taker will go for the higher risk, which is this one. So he will go for equity 2, and then here the risk averse will go for equity 1. The risk averse will go for equity 1. As you see in your notes, these two are measures of risk. But in case they conflict, this one is taken to be superior. Conflicting means on the same thing, they tell you different things. On the same item. You see, like now here, to the risk taker, ukitumia standard deviation, inamwambia aende 1. But ukitumia CV, inamwambia aende 2. So the decision maker will be confused whether to follow CV or to follow standard deviation. The same case here. So that is what we call conflict. So in case they conflict, you go for, or you take the directions from coefficient of variation. But kama zimekubaliana hii imesema 1 na hapa 1, hapa 2 na 2, that's good. So down there you make a comment so that we can answer the examiner on the basis of minimizing risk. On the basis of minimizing risk, the investor should prefer equity 1. The investor should prefer equity 1 as guided by coefficient of variation. As guided by coefficient of variation. Coefficient of variation. And that's how you respond. The next thing is the probability that equity 2 pays a higher average rate of return than the rate paid by equity 1. So that one, nitakuachia utapanga nayo because you already have done probability, normal probability distribution. So you are supposed to draw something like this because they are following the normal probability distribution. We are dealing with the equity 2. So equity 2 here has a mean of 9.5 and a standard deviation of 1.8. A standard deviation of 1.8. So kunaulizwa, what is the probability that it can pay higher than equity 1? Now equity 1 naona inalipa what? 12. So we want this one to be higher than 12. X1 here, 12. Yeah. So draw hivyo kuacha afira tamaliza hiyo. So having said that, on your own, you will handle this question of May 2017. Question 2C. This question I think we solved when you were in descriptive statistics. We solved, but we already computed values. So you can either compute or you go to where we computed. We compute this. So the kupanga two, then you say who will choose what. Yeah, so you just do a table like this. So we solved when you were in descriptive statistics, and if we never solved, then you just compute because you already know how to compute the mean, you know how to compute standard deviation, you know how to compute the CV. Yeah. Good. Now from there, the next thing now is to, so that was about measurement of risks. Measurement of risks. So I want us to read question 2. So question 2, so decision-making process or steps. And this one is called single stage decisions. So I want to read, or rather to go through the notes as you have a question. So in question 2, tunaambiwa, suppose that you are the owner of a cake shop, the cake box. At the beginning of each day, you have to decide how many fresh cream cakes to stock in order to meet demand during the day. Each cake costs shillings 70 and sells for shillings 130. The cake cannot be stored overnight, and if any remain at the end of the day, they are sold off for shillings 30 each. An analysis of past sales data gives or given the following information. So we have all that. The number of cakes demanded per day, the frequency, the required. Now, the decision you have to make is how many cakes should be bought at the beginning of each day. When you are confronted with a situation like that, and you are told to make a decision, as you will see in your notes when you go through them, the very first step, we call it objective. So I think I does like I'm writing, because I'm giving you a summary, although I will explain everything. Now, an objective, it is what you want to achieve. It is the problem that you want to solve. It is the need that you want to satisfy. Now, here's what tumesoma. You are told, you assume you are the owner of the cake shop. So what do you think is your objective? Kama iduka ni yako. Victor, what would be your objective? Profit. Good. And not just profits, to maximize profits. Good. So I think I need is to maximize profit. So that is the first step in any decision making. As you make any decision, you must know, what do I want to get in this? As I say what I'm saying, as I do what I'm doing, as I go where I am going, what is it that I want to achieve? And this is very important, because at times we see many people just move, just do something, and they don't know what will be the end. Now, still at that point, how do we compute profit? Nancy, how do you compute profit? Good. It is revenue or price minus costs. Now, when we are in decision making, when we are in the topic of decision making, we use the word payoff. We use the word payoff more than the word profit. So, ukiona profit, it is the payoff. Ukiona the word payoff, when we are in the topic of decision making, we are simply talking about the profit. Now, this formula, we call it general formula. We call it general formula, and I'll be showing you the specific one. Step number 2 is called the options. Options. Now, an option, it is something that is within your control. It is what you can choose. Like in this case, kama hii duka ni yako. We already have said you are doing 2 things. You want to make profits. And what are the 2 things that you are doing? Selling and buying. Which one is within your control? Is the owner of the shop. Then it is buying. As the owner of the shop, you decide how many. Unaona kama hii shule. This school is also a case of buying and selling. Sisi kama Destiny, these are the chairs that we are selling. Ni sisi tuliamua tutaweka chairs tatu hapo. Sio nyinyi mlituambia. And that is within our control. Tukiamua kuwabadilisha from this room to another one, it is still within our control. But is it now the number of students we have in this class is our sales? Is it within our control? No. Yeah. So what is within your control is what we call the alternatives, the options. So here it is the purchases, or what we call the supply. So they can decide, and when we talk about the supply, they can decide to supply just 1, 2, 3, all 4 kits. From there, you go to the next step, which is called outcomes. Now, outcomes, they are called states of nature because they are beyond your control. So what is beyond your control, we already have said here, it is demand. It is demand, the sales. Now, this one, you have no choice. You have to wait until customers come. It is what in layman's language they call consequences. Choices have what? Consequences. You are not able to control them. Like now that you came to Destiny, you have no choice than to be taught QA by Kimani, whether you like it or not. You're not consulted. You have no choice than to do QA on Fridays and Mondays. When we change the timetable, we rarely consult you. Because those are consequences. Yeah, those are consequences. The next one is now you identify the type of the decision that you're dealing with. The type of decision that you're dealing with. And this identification is very simple. Unarudi hapa. Unaangalia how many options do you have and how many outcomes do you have. Kama ni moja moja, you see that it's one. That's why it's called what? Single. Because it's 1, 1. Maybe when we do the second one on the multiple, utaona tofauti. So this is single stage. Single stage. Single stage. Then from there, after you get the type of the decision, You compute payoff. You compute payoffs using specific formula. Using specific formula. You compute the payoffs when you're using the specific formula. So here huwa inapangwa as a table like this. We have the option. Now remember here option tumesema ni supply or the purchase. Then we have the outcome, which tumesema ni demand or the sales. Or the sales. Sasa specific formula huwa inatengenezwa hivi. I can see I have 3 minutes remaining, but kindly allow me to extend like by 5 minutes. You will watch in a way that absolutely quite step when we meet in the next lesson. Okay. Sasa hii specific formula unakuja ku specify hapa. We need to know the price. So the price, maybe first of all we need to know it is going to be units sold multiplied by selling price, that will be the revenue, minus units purchased multiplied by purchase cost, minus, unaona kuna ile tunaambiwa wanasema the cake cannot be stored, and if any remain at the end of they are sold off, so that is also a revenue, right? That's also a revenue. Units sold same day, so I need to specify same day. So sasa now that itakuwa revenue, units sold second day times selling price. That will give us now the profits. Sasa hivi inaitangwa specific what formula. It has expanded this one. So quickly copy that as a table. Units sold same day times selling price. I'm overhearing that Monday could be a holiday. I have not confirmed. In case it is a holiday, we will have our class from 8:30 to 10:30. In case it is a holiday. Actually, we can target to have a class from 8:30 to 1. Yes, obviously with a break of 30 minutes. If it is a holiday, but if it's not a holiday, tutapatana tu kawaida. So, nataka na tuende haraka. So option 1 is you can buy 1 cake. Now, if you buy 1 cake, demand turns to be 1. Demand is 1. So utafuata tu venye nafuata Alafu kuandika these figures tutakuwa tunaandika directly below these words You can avoid the signs because already the formula is there. So if you have bought 1 and customers have come 1, you sell 1 during the day, and this one is sold at what? 70, ama kama utaweka sign, sawa, times 70. You minus the units purchased 1 times each one of, we are selling at 130, we are selling at 130. Purchase cost is 70. Then plus, hakuna yenye imebaki ya kuuzwa times 30. So hiyo tutafuta baadaye. It is also possible. What is that here? It is also possible you get 2 customers coming. If you get 2 na umenunua moja, you just sell 1 at 130. You had bought 1 at 70, and there is nothing that remains for the second day. If 3 customers come, you still sell 1 because you are on a moja, and you are selling it at 130. You bought 1 at 70. There is nothing that has remained to be sold at 30. And if 4 customers come, the demand is 4, you still sell 1 at 130 because you have 1 at 70, and there is nothing that remains to be sold at 30. Now that is what happens if you have gone to the market and bought what? 1. So tuteremka hapo chini, yangu ni tarabu sababu elezi kateremka hapo chini. So tukiteremka hapo chini, we now look at what will happen kama tumeenda sokoni tukanunua 2. If you have bought 2, and only 1 customer comes, you sell 1 at 130, but you have purchased what? 2 at 70. Plus, kuna moja itabaki sasa ya kuuzwa the following day. Now unaiuza at 30. If 2 customers come, you sell 2 the same day at 130. Because you have bought 2 at 70. But there is nothing that now remains to be sold the following day. There is nothing that remains to be sold the following day. If 3 customers come, you just sell 2 because that is what you have at 130, and you already have bought 2 at 70. Plus, there is nothing that remains. That way, if 4 customers come, you just sell 2 at 130, 2 at 70, and 0 at 30. Hiyo mnafunga, tuende kwa 3. Tuende kwa 3 to wonder what happens if you now go to the market and bring 3 of them. If you buy 3 and only 1 customer comes, then you just sell 1 at 130, and you have bought 3 at 70. Then 2 remain unsold at that bowl. You sell them at that bowl. If 2 customers come, you sell 2 at 130. At 130. And you have bought 3 at 70. You have 1 remaining at 30. If 3 customers come, you sell 3 at 130. You have bought 3 at 70. And here, 0 remains at 30. And if 4 customers come, you sell 3 because you have 3 at 130. You have bought 3 at 70. And 0 remains to be sold at 30. Are you following? Okay. And let's now see what happens if you have bought 4. If you go to the market and buy 4. So if 1 customer comes, you sell 1 at 130. Because you have bought 4, so that means umebaki 3. 3 remain unsold. If 2 customers come, you sell 2, and you have bought 4, so 2 remain unsold. If 3 customers come, you sell 3 because you have bought 4 and 1 remain unsold. And here 4 because there are 4 customers and you have bought 4. You have bought 4 here and there is nothing that remains unsold. So basically that is what I would expect you to come with next time for the rest of them. So that you now go to the next step. So we stop there. Sorry, I have extended your time by 10 minutes. So nimesema kama Monday it will be declared a holiday, we will have a class from 8:30 to 1. Kama haitakuwa holiday, we will just meet the normal. Thank you so much.